Yes, sir. जाए ना
नमस्ते मैम।
Good afternoon, students.
Ma'am, you are muted, ma'am.
Have you all settled down?
Ma'am, your voice is low, ma'am.
Please take a mic from your teacher there and then speak one by one.
Ma'am, actually, your voice is low, ma'am.
Okay. Is it better now?
No, ma'am.
Now, is it better? Can you hear me clearly now?
Yes, ma'am.
Okay. So have you settled, all of you have settled down, I believe?
Yes, ma'am.
Okay. What is the status of your homework? Do you remember I gave you homework for writing all the quantum number values for a certain orbitals?
You are not audible.
Is my voice clear to you all now?
Ma'am, we are not able to hear you, ma'am.
Is it better now? Are you not able to hear me at all? If I'm testing with the other device, my voice seems to be okay. Please check it at your end. Do you remember that this was the homework I gave to you in the last class? Is there any sir or ma'am there in the class? See, do you have mic, and can you please take the mic and respond to me? Can you hear me, students? Yeah, I can hear your voice very clear. Please. Ma'am, can you tell me, am I audible to you or not?
Ma'am, your voice is slightly low, we hope. From the previous sessions, it seems to be low.
But when I checked with Zoom and another devices, it seems to be working fine. Can you fine tune your system better? In the meantime, I'll log in and then I'll log out and then log in again.
Now it's coming only, right? You can hear her. We can't hear. You have to remain quiet for that. Now she spoke, right? We were able to hear only.
When she's...
We will see to it. Go. We need not adjust all those things. Minimize it. Minimize the window and go.
See, we will
maintain pin drop silence.
ஏய் full screen பண்ண முடியாது.
Listen, answer
Double
the
click.
question. Unwanted topic we are going to do, please leave the session.
You
Do
கொடுக்கணும்.
not remain here. Nobody is going to complain you.
ரொம்ப டைம் ப்ராடக்ட்.
Ma'am, is the voice issue solved at your end?
Answer it.
Yes, ma'am.
Okay. Now, please tell me what is the status of homework which I gave it to you in the last class. Have you done it or you have completely forgotten it?
Ma'am, we didn't do that, ma'am.
Why? None of you have done that.
Ma'am, we had exam on this week, ma'am.
Now quickly start doing it. Write all the quantum number values for 2p2. I'm giving you 2 minutes. Please write 2p2, the values of N, L, M, and S. See, what is the problem? I do not want to hear any conversation between you. Please solve the question. This was your homework. Ma'am, can you just tell me why there is so much of a noise in the classroom?
Your voice seems to be slightly low. So we are trying to sort.
See, I have detected there is no issue at my end. Even if you say I will restart my system. In the meantime, I will request you to copy down the things and do your homework now.
Yes, that's ma'am, இதுல மட்டும் தான் கேக்குது. இதோட கனெக்ட் ஆயிருப்பா.
People remain and do the work. I will call Nirmala ma'am and sort it out. Don't touch anything. He has given you work.
So, what you have done for 2P2? Can anybody tell me? I believe I'm audible to all of you now.
Yes, ma'am.
Okay. So, what is the answer for 2P2?
Ma'am,
Yeah.
M is equal to 2.
Yes.
L is equal to 1.
Okay.
Mg is equal to -2.
Okay. Only -2 or something else?
Ml is equal to -2, -1, 0, 1, 2.
Okay. Okay. But you just tell me that you have got only 2 electrons. Then why do you need 6 values or 3 values, whatever you said?
பின்னாடி அது லைட்டா டச் பண்ணோனே எல்லாத்தையும் சொல்லுங்க சார். பின்னாடி இது பண்ணலாம். அவ்வளவுதான் இருக்கு.
இதுதான் அவ்வளவுதான்மா. இதுல இருக்கிறது இதுதான் இந்த வேர்ல்டு தான்.
ஸ்பீக்கருமே வந்தா ஆனா மைக்ல டெஸ்ட் பண்ணி
மைக்கு எதிர சொல்றேன். என்னடா பண்றீங்க?
Students, have you attempted all of them?
Yeah, it's not good.
Are you still facing the sound issue?
Yes, ma'am.
Okay, let me use my headphone if it works. Because from my end, I tried at Zoom and at everywhere. I tried to have a normal to conduct another meeting, but it was working fine. Let me check again.
ஃபர்ஸ்ட் அதுக்கப்புறமா இதெல்லாம் நிறைய வர சொல்றேன். இஷ்யூ ஏன்னா அதுல நிறைய
கொஞ்சம் போயிட்டா இருந்தா உங்களுக்கு கேட்கணும், போயிட்டாவே இருக்க மாட்டாங்க இவங்க.
கனெக்ட் ஆகும். நான் கால் பண்ணி
If you are remaining quiet, it will be audible only. If you remain quiet, it will be audible. You are making such a lot of noise such that her voice is not good. And you please remember that you are here for a class, not to have a chat and have a nice time over here. If you think so, please you can leave the session. There's a strict warning given. If I see anybody giggling or chatting over here, this will be the last session you will be here. Then you have to go and speak with principal ma'am for your misbehavior. The same silence needs to be maintained.
Now, have you solved the question, students?
Then I'll give you order. Those who are sitting at the back, please come front. The last 3 or 4 rows, come front. Then I'll give you audible.
Ma'am, am I audible to you?
Yes, ma'am.
Yes, ma'am.
So have you solved this question? See, if you haven't solved it, just give me go ahead so I can start solving the question with you.
What's the question?
The question or the homework you have, write all the quantum number values for 2p2, 5d4, 6s1, 4p, 7f14, and 4d as the last one. Can you see it on the screen?
Yes, ma'am.
Okay. I wish to speak to the student who gave me the answer for 2p2.
Huh?
Yeah.
You can say again, ma'am.
Okay, what's your good name, beta?
Zantanitama.
Okay. See, it is for all of the students, we need to understand when I have given you specifically 2p2. That means the value of n is 2, that is correct. What will be the value of p? Sorry, the L. Because it is p, so the value will be, we will be writing only 1. I have asked for the specific value, not the all the values, right? I have asked for the all quantum number values for 2p2. Now talking about M, the possible value. See, there is a difference between the possible values and all the values. The possible values for M will be -1, 0, and +1. But what do we have? We have only 2 electrons in 2p, right? So what we have to do, we will be using any 2 of them, not all 3 of them. Is it clear that out of these 3, use only 2 values? They can be anyone as of your choice. So that means I wish to choose only -1 and 0. And then we know, according to Hund's rule, the electron will be in 2 different orbitals and they will be of parallel spin, right? So that will be +12 and +12. Or you can write it as -12, -12. Is this clear to all of you or not?
Yes, ma'am.
Okay, now quickly write it for 5d4. And whenever any one of you is done, please speak. We have already lost some time in just resolving this issue. So we should be able to catch up with it. So what's the answer? For 5d4, yeah, anyone wants to give me the answer?
M is equal to 5, ma'am.
Very correct. Then
M is equal to 3, ma'am.
correct.
M is equal to -2, -1, 0, +1, +2.
What's your good name?
Jananita, ma'am.
Okay. See, as I told you, how many electrons do we have? We have only 4 electrons. Now, just do one thing. Once you have done L is equal to 3, draw how many electrons are there and how they will be fitted in d orbital, right? So you will be having 1, 2, 3, 4, and 5 like this. Is it clear? And then what you have to fill only 4 electrons. So what you will be doing? 1, 2, 3, and 4. We don't need the value of magnetic quantum number for the last one because we don't have an electron to fill it over there, isn't it? So I can discard any one of the values. For the time being, I'm discarding +2 value over here. That means, and all 4 electrons, as you can see on the screen, are of parallel spin. So again, it is your choice. Either write +12 4 times or write -12 4 times. Is it clear, students?
Yes, ma'am.
Okay. Now do the next one, 6s1. Quickly, it should not take this much long time. 6s1, n will be equal to, any one of you can answer this now. N is equal to?
6.
Someone from the boys should answer this question. N is equal to? N will be equal to 6, L will be equal to 0, M will be equal to 0, S will be equal to either you can write plus half or minus half. Have you got this answer or not?
What is the M value?
Ma'am, can you help me in communicating with these students? Yeah, I'm listening. Please speak.
Actually, they want you to explain the spin quantum, electron spin.
Can you explain the last step?
See, the last step I'm saying, now 6s1, I have to draw S1. There will be a lone electron. You can say it is moving clockwise or it is moving in anti-clockwise direction, right? So you can use either plus half or you can write minus half. It is your choice, right? If I wish to, I will just cut this one and say that if I wish, I can write S is equal to, my wish is S is equal to half, right? So I'll be writing S is equal to 1/2. You wish to write S is equal to minus half. Now, since there is only one electron, use either of these values. Is it clear, students?
Yes, ma'am.
Okay. What about the next one? The next one is 3f5. So that all of us know N will be equal to 3. Now, what will be the value of L? First of all, answer me. Do we have 3f or not? Okay, that means this is itself incorrect. You also get a such type. If you have your exams on this chapter, you might have got this particular question. Which of the following atomic orbitals is not possible? That was the reason I deliberately gave it to you 3f5, right? So please remember, you may get a question like this. So that means 3f is not 3f is not possible. So that means 3f5 will also not be possible. Now moving on to next one, 7f14. It should be easy one and you should be able to do this. 7f14. N is equal to 7. L will be equal to
3, ma'am.
good. Now, how many M values you require? Do you require all 7? Or do you require only some of them?
Some of them, ma'am.
Why? I told you, as soon as you see the number of electrons being mentioned as 14. Now, we know F has got 5 orbitals. What we should do? We should draw those 7 here. 1, 2, 3, 4, 5, 6, and 7. And then put the electrons according to Hund's rule, right? We'll be doing it 1, 2, 3, 4, 5, 6, 7. Then we will pair them up. 1, 2, 3, 4, 5, 6, 7. That means all the orbitals are being used and all of them are completely filled. That means I will be using the all 7 values ranging from -3, -2, -1, 0, +1, +2, +3. And all the spin quantum number values will be used. So what I will be writing? I will be writing 7 times +½ and 7 times -½. Right?
Yes, ma'am.
Okay. Quickly tell me what was the next and start doing that. And if you have already done me, please done it, then let me know what is that one. Yeah, we are left with 4D. Now, before you answer, I'll tell you one thing. From this discussion, from this question, it must be clear to you. Sometime teacher may give you the number, like she can or he can say 4P4, or if she writes simply 4P. You need to understand the difference between them. When the teacher has not written any number over it, that means you have to consider it as 4p6. That is 4p orbital is completely filled. Right? Similar, so that means what will be the difference in the values of quantum numbers for them? N is equal to 4 is for both of them. L is equal to 1 for both of them. M in this case will be, I'll be using -1, 0 and +1. Why? There are 4 electrons and I understand 3 will be singly occupied and 4th will be paired up. So I'm using all 3 of them. So I'll be using all 3 values of M. Talking about the S1, as you can see, 3 are of parallel spin and the 4th one is of anti-clockwise. So we'll be writing the values like this. But if the teacher has given me only 4p, I have to assume that 4p is completely filled. That is, it is having 6 electrons. So the values will be N is equal to 4, L is equal to 1, M is equal to -1, 0 +1, and spin will have all 6 values, right? 3 +½ and 3 -½. Is the difference and the purpose of putting the question like this clear to all of you? I'm waiting for your response, students.
Yes, ma'am.
Okay. So let's solve this question. What are the magnetic quantum number values for 3s, 4s, and 5s electrons?
Get the mic and answer.
What is the value of magnetic quantum number for 3s?
One, ma'am.
Yeah, 3s is the value of M for 3s is
1, ma'am.
1. Okay, the value of N is 3, L is How did you get 1?
Yeah, it's 0, ma'am.
L is 0. And what about magnetic quantum number? If L is 0, how can you have MK value as 5? Oh, sorry, 1. Should it also not be 0? Any doubts to any one of you? Okay, I believe there is no doubt. Now, let's take the 4s. The value of n will be 4. The value of L will be, quickly, L will be
0, ma'am.
0. Okay. And M will also be 0. If you talk about 5s, value of n will be 5. L will again be 0. So, be smart enough and be tactful enough. The value of magnetic quantum number depends on the shape of the orbital, whether it is S, P, D, or F, right? So that means all of them are going to have the same value of the magnetic quantum number, right? Now, have you done N plus L rule in your class, or do you have any doubts about it?
We have done, ma'am.
Okay, I believe then I'll just quickly run through this. That there are 2 rules or two cases for N plus applying N plus rule. Although it is not asked very frequently when we are living in the era of above, we usually do not ask about them, right? So we say that if N plus L value is different for different orbitals, electron first enter into orbital of sublevel with the lower N plus L value. For example, if I talk about 1s and 2s, you can see the sum of N plus L for 1s is 1 plus 0, that is 1, and for 2s is 2 plus 0, right? So that means electron will be filled first in 1s orbital. Just a quick recap for the second one also. If both the values are same, then electron enters first into an orbital with the lower N value. That means if I take an example of 2p and 3s, for 2p, N will be equal to 2, L will be equal to 1. The sum of both of them is going to be 3, right? Similarly, if I take 3s, then N will be 3, L will be 0. Sum in this case is again going to be 3. So that means electron will go into 2p first. That we can confirm it from above also. 1s2, 2s2, 2p6, 3s2, 3p6. Because 2p is having a lower value of principal quantum number. The electron will be filled here first. Now, before we move to the discovery of subatomic particles, do you have any idea what does Pauli's exclusion principle say? Can you define it for me? Pauli's exclusion principle. I'm not looking for the classical definition, but I'm looking for your understanding. What do you, if I give you a teacher, if I give you a, what do you call it, as a surprise test? So what will be your response? What is Pauli's exclusion principle? Do you have any idea, or should I start explaining it to you? But I'll appreciate if any one of you can tell me that first. Please, any one of you start speaking about it. You all of you said that you have many exams last week or maybe this week. And I believe structure of atom must be one of the chapters which is done in the school and has come in the exam. So what is your response?
Ma'am,
Yeah.
no two electrons have the same quantum numbers.
No two electrons have the same quantum number. Now, I'll tell you what is the correction required in this one. Let us see, we have lithium atom, atomic number 3, configuration as 1s2, 2s1. Let's write the quantum number values for this 2s1 electron. The value of n will be 2, L will be 0, M will be 0, S will be plus half, right? Now, I take another atom of lithium. This world is filled of, is having lakhs or uncountable number of lithium elements, right? So, for another atom of lithium, again, the third electron will have n is equal to 2, L is equal to 0, M is equal to 0, S will be equal to half. Now justify your statement. I'm just wanting to have a debate on it. No two electrons have the same quantum number, right? And I'm happy that somebody, I really do not know your name, and I'll be appreciating if you can tell me your name, and I'll try to remember that. See, when you say that, unless or until you speak, I cannot make improvement in your understanding. So no two electrons have the same quantum number. This is a definition what the students have given to me. Now my question is, can you see the two atoms of lithium having same quantum numbers value? Do you agree with me? Yes or no?
Yes, ma'am.
Okay. So what is the correction, or what is something which we have missed here? Think it over. See, your definition is, I'll say, without that particular thing is probably incorrect. Do you have any answers to my question? Now, look at what I am writing. No two electrons of an atom can. This is something which you were missing. Have, and I'll make the correction here also, have all the same quantum number values. Now it is clear and it is complete. These are two different atoms of lithium. Their third electron can always have the same quantum number values, right? Some of you might be wanting to discuss that they can be different if they have plus half and minus half. Completely agree. But in this world, whatever number of lithium atoms are there, at least some of them, not only one, some of them must be moving in a clockwise direction, right? So if you are writing your definition like this, that no two electrons have the same quantum number values, that is incorrect, because there is a proof that they are there. So please copy it down, remember in your minds, and always repeat this one. And I wish you should not make this mistake again, that in Pauli's exclusion principle, we say no two electrons of an atom can have the same quantum number values. Is this clear to all the students?
Yes, ma'am.
Okay. So now we will move to the other section of this chapter. Usually the chapter begins from here. I have picked it up from the ending part of it because that takes a lot of time, and by the time if I start covering this, we reach there, the charm of chapter is lost. You must have heard or read about this particular section in the class 9th also. So what we are talking? We are going to talk in brief that how the subatomic particles, that is proton, electron, and neutron, were discovered. It's a purely factual section, but a detailed eye, like as I have just shared that example, you have understood Pauli's exclusion principle, you know everything, but there has to be an eye for the detail. So just recap or whatever you have already learned. I understand that you have learned, but I will be recapping only or emphasizing only on the important points. So first of all, if I ask you discharge tube, what is a discharge tube? Again, I'm putting this question, I'm explaining it because it will be carried to class 12th also in certain parts. And then you have to know the basic definitions correctly. So the discharge tube is nothing but a sealed glass tube which is filled with a gas and has a metal electrodes. Electrodes are there to conduct the electricity. Now, first, the discharge tube was discovered or rather made by William Crookes, right? And he noticed that the gases are poor conductor of electricity if high voltage and low pressure is applied. Otherwise, if you reverse the condition, now this point, high voltage and low pressure is important for attempting many multiple choice question. Imagine if you use low voltage, you reverse both of them. This high if converted to low and this very low converted to very high, right? The gases will become conducting, right? They will show their own properties. It won't be possible to conduct any experiment. So we must remember from this particular slide or with this particular screen that in the discharge tube, whenever you are working, you should be working at high voltage and low pressure, right? Now, moving to what are cathode rays? The cathode rays, we describe them, cathode rays are made up of electrons. So we say they are beams of electron which travel from cathode to anode. As you can see the arrows here, right? They are moving from cathode to anode. I have marked it with a brown colored arrow. I believe it is visible to all of you, right? So they are produced only when in the discharge tube, the gases are present or the discharge tube is filled with a gas at a low temperature. It was J.J. Thomson, the famous scientist, who studies the cathode rays and constitutional properties. Constitutional property means the material of which they are made up of, right? So that is about the most important thing, that they move from cathode to anode, right? They originate from cathode. So it is just a quick recap of important point. They move from cathode towards the anode. The second one, they themselves are not visible. Most of the gases which are used in the discharge tube experiments, they are colorless, but they produce fluorescence and phosphorescence. Fluorescence and phosphorescence, see, you might during Diwali or sometimes I have seen on Amazon or any other site that there are few things which shine at night. They put it on the roof of your room, and it appears as when there is no light. It appears as if they are shining, right? There are certain flies. We call them in a jugnu in Hindi. I think they are called as fireflies in English. If you go to the village side, you may see fireflies at the night, right? So that means we just need to understand there are certain materials which shine at their own. When some light falls on it, like if you are a fan of driving or if you drive through car, on a highway, you must notice it. If you do not put on the light in your car, you cannot see the road, because road has reflectors which have either fluorescent or the phosphorescent material on them. So when the light is put on them, they start shining or they start glowing. So gases cannot be seen, as if it is similar situation as we are sitting in the room, but we can feel the presence of oxygen. We can feel the presence of air, in fact, but we cannot see it. But you can see it through indirect ways, through phosphorescence or fluorescence, right? And in the discharge tube experiment, if neither electric field nor magnetic field is applied, they move in a straight line. Remember, this is important. In the sample paper, this is one of the questions, right? How do cathode rays travel? They travel in a straight line. The condition is you must not apply electrical or magnetic field on them. Then, the cathode rays are always attracted towards the positively charged electrode. That means they themselves are made up of negatively charged particles, which were named as electrons. Then the characteristics of electron, that is E by M, the charge by mass ratio, that does not depend on the material of electrode. Like if it is sultry hot in your area these days, you must wear cotton clothes. And if it is raining, you can wear different type. You should wear a synthetic type of a cloth in the form of a raincoat. So choice of material for making cloth depends on the weather, right? And both of them are going to protect you. But in case of cathode rays, they are always found to be made up of electrons having the similar charge and similar mass. That means material of an electrode does not change the characteristics of cathode rays or electrons. This is just a nutshell of what are cathode rays. We have already done it and you must be knowing. Anybody having any issues with cathode rays or anode rays topic? Okay.
No, ma'am.
Okay. Now we will talk about the anode rays, which are made up of positive charge. I will be doing it quickly because, as you said, you know all of them, right? So they are also known as canal rays because they pass through canals or the holes of cathode. So the other name of this is important. Please remember, and not only for this particular thing, whenever any name comes, if a substance or a compound or element, whatever it is, or even an experiment is known by more than one names, please remember all the names, right? They are, as we said, they are positively charged, and their charge depend on the material of the gas. They can be unipositive, they can be dipositive, they can be tripositive, right? So that's what we technically call it as. Some of them are positive. Some of the positively charged particles carry a multiple of the fundamental unit of electrical charge. If I take the example of magnesium 2+, right? This 2+ means it is having 2+ charges. This is multiple of unit positive charge, right? So their behavior, they are made up of positively charged particles. So they will be having an opposite behavior as the cathode rays were doing. Now, these are the properties of anode rays. You just have to remember the most important one is they produce fluorescence. They produce, I say, a sort of a shining image when used on zinc sulfide screen. Rest of the properties we have already done, right? Then how neutron was discovered? It is done in a very, very concise manner in your book, but we must remember the name of the element which helped in discovery of neutrons. That was this. Can you name this element? This one is? The name of this element is? Any answer? It is an isotope of beryllium. It is written on the screen itself. Now this one would be difficult. We call this as a alpha particle. Alpha particles are nucleus of helium. We'll take about the alpha, beta, and gamma rays in the next class. If you know about them, let me know. What are alpha, beta, and gamma rays?
Yes, ma'am.
Okay, tell me what is a beta ray? Any idea? Students, quickly respond whether you know it or not.
Ma'am, we don't know, ma'am.
But I heard somebody said yes. Okay, we'll discuss about them in the next class. Quickly, let us see. First of all, neutron is one of the latest particle, 1932. Others were discovered in 1918 and 1904. Yeah?
Is that negative ions, ma'am?
Which one?
Beta.
Beta is a negative ion, but what is it made up of? I told you, helium, alpha particle are nucleus of helium.
Ions, ma'am.
So, what is a beta particle? It is made up of blank. Now, fill this blank.
Ma'am, made up of anions, ma'am.
No, they are not made up of anions. I'm just to answer your query, I'll just say that for the time being, we need to understand them in a bit elaborate manner. For the time being, you can understand that beta particles are electrons and they originate from nucleus. Isn't it amazing? That's an interesting fact about it, right? We'll discuss about them. Don't worry about it. See, radioactivity has been removed from CBSE syllabus, that I agree. But alpha particles, beta particle, gamma particles, you will have to study. If I teach you here, they will be sufficient enough for you to understand whenever they are used in this class as well as in the class 12. When we talk about chemical kinetics, they are definitely need to be there, right? And in the competitive exams, alpha, beta, gamma particles are always there. So we'll talk about them. But if I talk about, I'll just give you a brief idea what is a gamma particle. Gamma particles are simply energy particle. They do not have mass. They are just energy particles, right? It is something like that. When it's sultry hot at 42, 43 degrees centigrade, when we come in front of our AC, what we do? We deep breathe a lot to give out the excess energy. So whenever radioactivity process is going on, a lot of energy changes are taking place. That means to settle down, to make them come back to their ground state, we must emit something. So they emit gamma particles. That's a brief description of what are alpha, beta, and gamma particles. Now, the discovery of neutron was late. That is one of the general question. Why neutrons were discovered so late? There is one thing we say, because they are neutral. They never show any. See, we understand that atom cannot be seen. If atom cannot be seen, then subatomic particles can also not be seen, right? But proton and electron, luckily they were charged, or they are charged. So whenever they are put into magnetic field, electric field, they show their presence. You cannot see them, but you can feel their presence. But discovery of neutron took a lot of time for the scientists to do, because it is neutral. It does not have a charge on it, right? So these are the details which you must remember. The mass of proton and electron. It helps you in solving some of the questions of Bohr's atomic model and some of the other aspects also. Sometimes when they ask how many moles of electron or how many moles of proton or neutron are found, then for finding a mole, you must remember that you have to put the value of mass. So if the teacher has not given you deliberately, if you know that, you'll be able to solve that easy question, right? Now, moving on, we'll be discussing about the atomic models in the next class. Why the atomic models were important, and why do we have to make a model? You must have seen that whenever a big building or a flyover is made, first of all, the people make the model. Yeah?
And actually, this is the time for discussion, ma'am.
Okay. Then we'll continue with the atomic models in the next class. If you have any doubt from whatever we have learned today about the subatomic particles and the different quantum numbers, you can ask me, else we can end the class now.
Okay, ma'am. Thank you, ma'am.
Welcome.